In the early 1960s, Ed Lorenz was experimenting with computational atmospheric models at MIT. The work Ed was involved in used a computer to model the development of a very simplified atmosphere. In order to be able to repeat a run, he would write down the state of the system. In theory, he should be able to duplicate a simulation at any time by starting the simulation from the recorded parameters. And the simulation would be exactly the same no matter how many times you ran it. In other words, the simulation was deterministic based on the starting parameters. At some point he ran a simulation with the numbers he had written down, but to his astonishment, the results of the simulation came out totally different to the first run. What had gone wrong? It turned out that he had written down only the starting parameters to 3 decimal places. The numbers were actually represented inside the computer to several decimal places. So while the initial values were very close, they were not identical. This small difference in initial value caused the simulations to diverge to the point of being totally different over a short period. In our normal common sense experience, a small change in some value shouldn't have a small effect. For example, if we're baking cookies, adding too much sugar or too little sugar will not greatly change the quality. However, in dynamic systems like the weather, a small change in initial conditions can cause a total divergence. The importance of this to weather was fundamental. It gave the science of meteorology a definitive theoretical basis to work out the limitations there were on the accuracy of forecasts. What Ed Lorenz discovered was an example of deterministic chaos. Deterministic chaos provides an insight into the limitations of upfront design and planning. It is generally accepted that the earlier a defect is found, the less it will cost to fix. For example, if there is a defect in the requirements, it costs much less to find it and fix it in the requirement stage than finding it after you have designed and coded the wrong functionality. Like the weather, software projects are very sensitive to initial conditions. A small change to the requirements can translate into a large change to the completed project. This characteristic of software development has been used to argue that projects should put a large investment into upfront design to avoid the cost of developing the wrong features. Clearly, doing some upfront design is much better than doing no design at all. The success of companies who have employed design processes proves this approach is more successful than companies who employ poor software design methods. However, what I do see is, like the weather, it may be possible to plan in detail a few days or weeks into the future, but it isn't possible to plan a few months or years into the future. Projects which aim to plan in detail the design of software systems that will take years to develop will inevitably fall victim to the same issue as the weather. The problem is that very small issues in the requirements can have effects out of all proportion to the final development time.